This video covers the Fifth Avenue Industries product mix problem in Chapter 3. In Section 3.2, Tables 3.1 and 3.2, we're provided with the information that we need to use linear programming to solve the product mix problem faced by Fifth Avenue Industries. Fifth Avenue Industries is a manufacturer of menswear which produces 4 varieties of ties. That information is provided in the 2 tables. In addition to the costs of material for the ties, there is availability information, selling price, contract minimums, monthly demands, the requirements of each material per tie. All of that information is provided, which is plenty for us to construct our solution. Now, if you don't have your worksheet set up like this, you want to pause the video and enter these values into these cells. Try to put them in the same cells so that your formulas will match my formulas. We will add more to this as we work through it, but this is a good starting point for us. The first question we want to ask ourselves when constructing a linear programming problem is, what is it that we're making? What's the output, the end product? In this case, we're asked to make all silk, all poly ties, as well as 2 types of blend ties, blend 1 and blend 2. So those are the products that we'll be making. Now what we want to do is determine how many of each we want to make. This is going to be our solution set. And I'm going to color that yellow just so we can keep in mind this is the solution row. Now this is a profit maximization problem, but we're not given profit per tie. We are given the information that we need to calculate profit per tie. And this happens a lot in blending products. It's nice when they just give you the profit per tie and you can move forward. But in this case, we're given the selling price per tie, which is $6.70 for the all silk, $3.55 for the all poly, $4.31 for blend 1, and $4.81 for blend 2. In the paragraph above the tables, we're provided with the labor cost per tie, a standard labor cost of 75 cents per tie. So 75, 75, 75, and 75. 75 cents per tie. We're also provided with the material costs per tie in the table because we're told the amount of material that is required for each tie and the cost per yard of that material. The material requirement per tie is provided in yards. The cost of material is provided in yards. So that's a good thing. So we have to calculate the material cost, but we're going to let Excel do that calculation as we set things up. So profit here is then going to be our selling price less the labor cost per tie less the material cost per tie, which we will calculate in a moment. Move that across. That provides us with our profit. And once we've calculated those material costs, we will then have our profit. Profit is what we want to maximize. We're going to use Solver to maximize profit based on a series of constraints. So I'm going to shade this cell green just so we can spot it. Keep in mind that profit is what we're maximizing. Now let's take a look at our constraints. First of all, we have our material constraints, and I want to talk about these content type constraints, things that go into a product, things that a product contains. We have 3 constraints. we have only so many yards of silk, so many yards of polyester, and so many yards of cotton. So our constraints are yards silk, yards poly, and yards cotton. Now, each time we make a tie, we use some of these materials. So let's indicate how much material is used each time we make a tie. When we make an all silk, we use 0.125 yards. We don't use any poly or cotton in an all silk tie. In an all poly tie, we use 0.08 yards, according to the table. In blend 1, we blend poly and cotton, 0.05 yards poly and 0.05 yards cotton. And for blend 2, it's 0.03 yards poly and 0.07 yards cotton. And we're told that we have, let's put our constraints over here, column H. We have 1,000 yards of silk, 2,000 yards of poly, and 1,250 yards. I'm going to go ahead and just format that column a little bit. This will be the column where we put our constraints. I'll label that because I want to calculate pricing here a little bit differently than we do sometimes. They show us in the text, and it's a good idea when you are calculating the material cost based on a unit of measure, so per yard, and the items that you're using use only a portion of that, or they use a combination, some from this material, some from that material, which is the case here. So I'm going to go ahead and put my cost per yard for each of the materials right here. And it's $20 a yard for the silk we get from the table in the text, $6 a yard for the polyester, and $9 a yard for the cotton. Now that allows me to use the sum product to calculate my material cost. I can do this in one formula in Excel. I'm going to use sum product to take the values in this column. So how much silk, how much poly, how much cotton am I using? In this case, 0 poly and cotton. Leave those relative, and then go over here to the costs for each of those and make that absolute. And that will use the sum product then to go over and multiply the yards of silk times the cost of silk plus the yards of poly times the cost of poly plus the yards of cotton times the cost of cotton. In this case, it's only silk. But as I copy it across, you can see then that it is calculating the material cost for each of those as it moves across. So it's a nice way to do that in linear programming. Now that we have the content constraints out of the way, we have some quantity constraints to deal with. We have monthly demand figures, which is the most we want to make. We don't want to make more than we can sell. In this case, we're not making for stock. We're trying to sell these things. And we have some contract minimums. We have buyers already lined up, so we want to make at least this amount. So let's go ahead and put in our demand numbers first. So we have a max silk constraint. We don't want to make any more than that. Max poly. We have a max blend 1 and a max blend 2. And we'll go ahead and put those constraint values in. We see from the table the monthly demand figures: 7,000, 14,000, 16,000, and 8,500 for those values. Now, Let's go ahead and turn these on then. So every time we make a silk tie, we want that to count toward our silk demand maximum. So we'll count that every time we make a silk. Except here, every time we make an all poly tie, we want that to count against our max poly. So we'll count 1. Every time we do blend 1, we're going to count a blend 1 against our maximum. And every time we make a blend 2, we'll count a blend 2 against the production maximum. Now we have some contract minimums. We need to fill contracts, so we don't want to make any less than these. We have a minimum for silk. We have a minimum for poly. A minimum for blend 1 and a minimum for blend 2. Those minimums we'll put over here. Monthly contract for silk is 6,000. It's 10,000 for all poly. 13,000 for blend 1 and 6,000 for blend 2. And each time we make one of these, each time we make an all silk, let's count that against our all silk minimum. Each time we make an all poly, we'll count that against our all poly minimum. Each time we make a blend 1 against the blend 1 minimum, and a blend 2 against the blend 2 minimum. Let's put in some signs. This is kind of just a visual cue to keep in mind how we're going to put these constraints into Solver. We know that these are maximum constraints, so this is all the material we have, and these are all the ties we want to make down to here. So we want to make less than or equal to each of these quantities. We can't go over these. These, on the other hand, are minimum constraints. We have to make at least this many. So these are greater than or equal to constraints. We have contracts to fill. We can't make any less than these. Now, I'll go ahead. This will be the solution as far as how much of each material or how many ties we make. Right here, I'm going to color code that so you can see the result. I'll make that blue. Now we need to put in our sum product values so that we can use Solver to solve this. Solver has to be able to put values in the yellow here that will change values here so that the logic can be applied against this, so a solution can be found. So we'll use sum product, and it's the same all the way down. Sum product, we take the solution set, we make that absolute, comma, the row to our left. We'll come down here and do it again, equals sum product. The solution set, we make that absolute, comma, the row to my left. Once I've done that, I can just copy these down all the way. I have the same background color. All right, now I'm ready to go with Solver. I place my cursor in the green cell because I know that's the first thing that Solver is going to look for when it opens. I go to the Data tab. I don't see Solver here, so I don't have Solver loaded. So I need to go to File, Options, Add in, Manage, and click Go. Select Analysis to Opaque and Solver. Say OK. Now Solver appears right over here in my Data tab. So I'll click Solver. This is a profit maximization problem. This is the objective that we're setting. We want to maximize profit, and this is going to be profit. we set it to maximize. If it was cost, we'd be minimizing cost. We always maximize profit. We always minimize cost. We're going to do this by changing the values in the yellow cells. We're going to decide how many of each of these we're going to make based on these constraints to make the most profit we can. Here are the constraints. We're going to add them. I usually take this and kind of line it up so I can see this symbol with this. Here are my less than or equal to constraints. I'll just start with those. Here are the cell references for those constraints. Then here are the constraints themselves. Be careful not to go over. Then I have one to add. I have some greater than or equal to constraints. I'll just select those. I'll change this to greater than or equal to. Then the constraints, careful to get those. Good. No more to add, so I click OK. Now I'm going to go ahead and make this a simplex LP model. We'll be doing that every time when we do our linear programming. This is a simplex linear programming model. I'm going to make sure that they make unconstrained variables non-negative box is checked. That needs to be checked. Then I'll select solve. Solver comes up with a solution. In a little bit we'll be doing sensitivity analysis, but for now we'll just go ahead and let Solver provide us with the solution. So I select OK. Let me make this a little lighter green here, a little easier to see. The solution here is 120,196. That's the most profit we'll be able to make. To do that, we will make 7,000 all silk, 13,625 all poly, 13,100 blend 1, and 8,500 blend 2. As we look down here, we see we have some non-binding constraints, so we don't use all of our silk. We do use all of our polyesters. That's a binding constraint. We use all of our cotton. Again, a binding constraint. You can look down and see how we have applied our resources to get the maximum profit. That's how you solve the profit maximization product mix problem in section 3.2 of the textbook.